Good morning and welcome to Mission Control Houston. You're looking into the Johnson Space Center's Flight Control Room, where the hardworking ground team is monitoring all the ongoing activity high above, on board the International Space Station. The crew I'm sitting among right here has been kept pretty busy the past few days, assisting the crew on orbit with a variety of activities. It all kicked off on Monday with a very important and very speedy delivery. But of course, that was far from all the crew had on its plate this week. Here's a look at what they've been up to.
Houston Station on Space to Ground.
Welcome to Space to Ground. I'm Dan Hewitt. A Russian cargo vehicle just went on a fast-track ride to the International Space Station. The Russian Progress 70 lifted off from the Baikonur Cosmodrome this week, flying atop a Soyuz 2.18 booster. After just under 9 minutes of flight, the uncrewed cargo craft was in orbit and ready to chase down the station. It arrived just about 4 hours later after circling the globe twice, which is about twice as fast as usual. This successful demonstration could become the norm for future cargo and crew launches on Russian vehicles. Meanwhile, some exciting new research to help combat cancer took place inside the station. The AngieX Cancer Therapy Study is using microgravity to study a treatment that targets tumor cells and the blood vessels that can supply them. NASA's Serena Aunon Chancellor, a physician and former flight surgeon, operated a microscope and processed samples for the study, which is hoping to eventually lead to the development of safer drugs that target the vasculature or blood supply of cancer tumors. This week's question comes from Daniela, who wanted to know how many rooms are there on the space station. Well, each module is essentially its own room, so there are 10 big ones and 5 smaller ones. The big ones are Kibo, Harmony, Columbus, Destiny, Unity, Tranquility, Quest, the PMM, Zarya, and Zvezda. The little ones are the Cupola, Beam, Piers, Rassvet, and Poist. Keep sending us your questions using the hashtag #SpaceToGround. And be sure to check out the latest demonstration on our YouTube channel, where Ricky Arnold teaches us about surface tension. We'll see you next week.
Off the Earth, for the Earth. Space to Ground.
The crew will say goodbye to a different recently delivered cargo spacecraft when Cygnus departs the station this weekend. You can follow along with that coverage live here on NASA TV as well as online, all kicking off at 8:15 a.m. Eastern Time this Sunday morning. And as I mentioned earlier, it takes quite a team to ensure that those operations and all others run smoothly for the International Space Station. And the leader of that team, the flight director, holds the overall responsibility to manage and carry out all human spaceflight missions. It's a big job, and just this week, NASA named 6 new flight directors to take it on. Those flight directors and their colleagues here in Houston will be in charge of the future missions out into the solar system on board the Orion spacecraft. In just the past 3 months, the teams across America and in Europe that are developing and building that spacecraft and that rocket and that infrastructure necessary to send humans to deep space destinations, they've reached many milestones themselves. Take a look at some of their most recent achievements. In order to support all those future deep space missions, scientists in NASA's Human Research Program have been trying to figure out exactly what dangers such a long-duration spaceflight could pose for human explorers, and then how to protect those crews that are chosen for those missions. Some of that research is being done on orbit, but some of it is being done at NASA's Space Radiation Laboratory.
The NASA Space Radiation Laboratory is an outgrowth of Brookhaven National Laboratory's particle accelerator. It utilizes the heavy charged particle radiation beam from various components already existing at Brookhaven Lab to then deliver specific doses, ions, and energies of radiation to the actual NASA Space Radiation Lab itself, with the goal to determine the potential risks to human beings from exposure to radiation during space travel.
The bulk of the radiobiology data that we've collected from the NASA Space Radiation Research Laboratory has really helped us establish our space permissible exposure limits. NASA has a set of limits that helps protect the astronauts not only from the short-term effects of radiation, but also the long-term health effects. In order to establish what those limits should be, we have to understand how space radiation is different than terrestrial radiation. And the experiments at NSRL has helped us establish our permissible exposure limits in terms of protecting the crew from the risk of radiation carcinogenesis, and also setting non-cancer career limits to the brain for central nervous system effects, and also to the heart for cardiovascular disease.
The primary difference with trying to compare what type of radiation dose an astronaut would get on a mission to Mars versus what a person could expect in their day-to-day life over time is that time factor. Now, a mission to Mars, depending on when you go and how the planets are aligned and such, you're still looking at approximately a 2 to 3 year mission. And while that seems like a long time, it's very different than the amount of time that, say, a non-astronaut, just a regular person that has nothing to do with space travel gets over, say, a 70, 80-year lifespan from, say, some radon gas in the home, or from medical tests that are administered where you get a certain amount of dose from CT scans or PET scans and X-rays through the course of life. So you're delivering a certain amount of radiation dose in a more compressed period of time than you would to the person that has never been a space traveler and such. And that's one of the trickiest aspects to trying to determine radiation dose. The same amount of radiation dose delivered in a day is very different than that same dose delivered in 3 years, even though, well, it's the same dose. It's not that simple, and that has to be evaluated when you try to determine the potential risks of absorbing that kind of a dose.
Even more science is underway by the station's crew to learn what kind of effects the microgravity environment can have on the human body. Researchers now want to find out more specifically about the immune system. And to do so, there is a new experiment on board looking into how that critical system will be affected during a mission out into the solar system.
Your immune system in space. Presented by Science at NASA. Getting sick when you're far from home is a drag. You'd give anything to crawl into your own soft bed and sleep, but you're stuck in a cookie-cutter hotel room feeling like a sick fish out of water. Well, it could be worse. You could be an astronaut on the way to Mars, a really long way from Mom's chicken soup. Future space travelers will need to stay healthy to perform well for their own safety and for mission success. So it's important to understand how extended space travel will affect them. The immune system works unnoticed to protect the body. But even subtle changes in that all-important system may be linked to the onset of illness. Factors like radiation, microgravity, stress, and altered sleep cycles could all affect astronaut immune systems. A new NASA study entitled Functional Immune will investigate the immune system changes that occur in International Space Station, or ISS, crew members. Understanding these immune system changes may help scientists pinpoint the onset of illness and suggest monitoring strategies or treatments that can boost the immune system and prevent full-blown infections and diseases here on Earth. Functional Immune builds upon the results of several previous NASA studies of the immune system, which, according to Johns Hopkins University scientist Dr. Mark Shellhammer, tell us there is no place during spaceflight where we see stabilization of the immune system. In 2014, NASA's Integrated Immune Study showed abnormalities can occur in immune cells in ISS crew members' blood during flight. Normally, the immune system attacks and eliminates virus-infected cells. When cell activity is depressed, the immune system isn't responding to threats as it should. When cell activity heightens, the immune system reacts excessively, which can result in illness, increased allergy symptoms, and persistent rashes. ISS crews were also observed to experience reactivation of latent viruses from childhood, a finding directly related to reduced immune function. The Integrated Immune Team, working with the NASA Nutrition Laboratory, also measured the concentration of cytokines in blood plasma, the proteins that marshal the forces to an infected or injured body site to defend against invaders. The data indicated that changes can be seen in blood cytokines just as changes can be seen in cell function. Dr. Brian Cruchon of NASA's Johnson Space Center, or JSC, principal investigator of the Functional Immune Study, says, "The immune system is very complex, and several aspects of immunity remain uninvestigated during spaceflight. We now need to delve deeper into the immune system changes that happen in space, and also determine if immune changes during flight elevate clinical risks for astronauts in future deep space missions. All the factors that change immunity on the ISS will be worse on longer missions to an asteroid or to Mars." Functional Immune includes NASA scientists and external collaborators at the Johnson Space Center Radiation Lab, the University of Houston, and the State University of New York. The study will reach beyond any previous space immune study and include exciting newer tests such as transcriptomics and proteomics. These tests will happen in parallel with the assessment of immune cells in blood, stress, and virus reactivation. Cruchon says with the ISS, we have a unique opportunity to study very healthy people in a quasi-isolation chamber, yet experiencing all the stressors that are specific to spaceflight. Results should help clarify the influence of spaceflight-specific environmental factors on immunity and identify countermeasures to mitigate their effects. These studies could improve scientists' understanding of the immune system, making a positive impact on human health at home and while traveling both near and far. For more from the International Space Station, go to www.nasa.gov/station. For more news about spaceflight and the strange things it does to the human body, visit science.nasa.gov.
Robotic technology, originally developed for the International Space Station, has also found a way to help humans here on Earth in the operating room. And to make that happen, a few companies worked together to create Drive, an automatic robotic arm that tracks the movement of a surgeon's tools and helps to expedite brain and spinal surgeries.
The International Space Station is probably the most fantastic vehicle ever built.
It's a one-of-a-kind laboratory orbiting about 250 miles above the Earth.
And we perform experiments on the International Space Station.
We can do science, we can do experiments, we can learn how to do things out of this world.
And the result will help benefit the people on the ground.
So not only that, but we're also seeing benefits of how we actually assembled the space station.
So the International Space Station in its design was essentially designed like a Lego toy. Lots of big pieces that need to be put together. Some of these pieces are going to be about the size of a city bus.
We needed a way of manipulating or moving these big pieces and very precisely putting them together.
Canada worked with its contractor, which was MDA, and with that company came up with a design that was going to meet the needs of the International Space Station.
The solution to that was using a fairly large robotic arm. And that system ended up being Canadarm2. It could move around the space station, grab payloads, move them to where they needed to be so that the space station could be assembled.
You couldn't have built a vehicle like the International Space Station without a robotic system like this.
And that was when we started talking to Synaptive Medical.
Knowing that MDA has done this before in space, we thought it would be very easy for them to bring that experience and that technology into the neurosurgical area and help us with our medical robotics. We worked with MDA to create Drive. Drive is a robot mounted onto a base that holds a surgical camera that can be automatically positioned to any surgical instrument that's tracked by our system.
What this arm does, it follows you and it tracks you, so it speeds up efficiency.
Ultimately, using the Drive system allows the surgeon to have shorter surgical times, which means shorter recovery times for the patient, and ultimately that's better for the hospital and the patient.
But what the robot does for us is that it allows us to do it safer. You can do it better with less harm to the patient.
The software that runs on the Drive system is directly derived from the software that runs the Canadarm2 on the International Space Station.
Those robotics work with and alongside an astronaut to enhance what they do. So that connection is a very direct and real one.
Right now, it's probably the most used system that we could say is derived from the things we did on the space station, and we're pretty proud of that.
And I've seen the arm before, we've seen it on the space station, but, I never put the two and two together that I'd have the same arm in the OR at some time now.
I think everybody has this dream of how robotics are going to become more and more a part of everyday life. The things that we do with robotics on the space station is basically pushing those dreams forward. And we evolve the system, we gain the knowledge, we gain the experience, the expertise. So this is kind of the unexpected benefits that we get out of doing a program like the International Space Station.
From space to the operating room to the classroom, this year our astronauts have been spending part of their time on activities designed specifically to help teachers and students get the most out of learning about science, technology, engineering, and math. During this year of education on station, our station crew members have already walked us through so many scientific topics, including some like Newton's third law of motion.
Welcome to the International Space Station. I'm NASA astronaut Mark Vande Hei. Today, we're going to talk about Newton's third law. How do you think it will hold up in microgravity?
For every action, there is an equal and opposite reaction. This means that in every interaction between two objects, there are a pair of opposite forces acting on each object at the same time, a force pair. You can see that there are many examples on Earth. In space, thrusters expel one way and the vehicle is steered in the opposite way.
Hello again. More basketball stunts that I can't do on the ground, at least not while getting this much hang time. All right, back to serious business. We've got a basketball right here. It's going to be object 1. I'm the second object. If object 2, myself, applies a force to object 1, then that same force will be applied, according to Newton's third law, by object 1 onto object 2. However, there's a big disparity in the mass. Object 1 is a very light mass object. Object 2, myself, is a larger mass object. So, I'm going to try to make myself about the same shape as this ball. See how that works for us. And I'm going to apply that force. You saw that force applied to the ball made it accelerate quite a bit. It really didn't accelerate me much at all. Newton's third law again, but this time we're going to use two similarly massed objects. Joe and I have about the same mass, so Joe, get into a ball, I'll do the same. I'm going to face you this way so I don't throw you into something you can't see. Now I'm going to get into a ball behind Joe, and I'm going to apply a force to him. Notice that when I applied a force to Joe, it accelerated Joe away from me, but I got accelerated away from him as well, because the force applied to Joe ended up being the same force that was applied to me. Now you've seen Newton's third law in space. Now test it out on Earth. See you next time.
As you know, a former classroom teacher is on board the International Space Station as we speak. Having launched back in March of this year, astronaut Ricky Arnold is now in the second half of his first long-duration stay in space. And before he launched, he was sure his time on orbit would only add to the very interesting experiences he's already had in the classroom.
I graduated from college and was working at the United States Naval Academy in the oceanography department, and that's when I first considered becoming a teacher. My first teaching job was at the John Hanson Middle School in Waldorf, Maryland, and even though I was a science teacher, I actually taught 2 classes of social studies to go along with four classes of science. I coached high school basketball in Maryland at the Thomas Stone High School, as well as in Casablanca, Morocco, and in Bucharest, Romania. I played a guitar in rock and roll bands with fellow faculty members, administrators, and even some parents, both in Casablanca, Morocco, and in Bucharest, Romania. My first teaching job was in an open space science classroom with no running water. And I realized when I could get through my first year of teaching, I had really accomplished something.
If you'd like to take another look at the stories we featured today, you can find them on YouTube and Facebook at those addresses right there in that little blue box on your NASA TV screen. While you're there, feel free to do a little exploration yourself and find a lot more on NASA and America's human spaceflight program. And if you're interested in learning more about space exploration by way of some good conversation, you can check out Houston, We Have a Podcast. On the podcast, you'll get to hear all sorts of NASA pros talking about their work and their personal experiences on the job. New episodes post on Fridays, so today, on July 13th, my colleague Gary Jordan is talking with astronaut Stan Love. He's going to tell us more about the real nuts and bolts reasons why putting people on the planet Mars is a hard thing to accomplish. To check that out, go to www.nasa.gov/Johnson/HWHAP. As in Houston, we have a podcast. You can also listen on iTunes, Google Play, and on SoundCloud. Well, until next time, this is Mission Control Houston.
To the Russian segment and checked out the number 1028 in the S, and it doesn't look any different than it normally looks. Everything looks nominal, except the only thing I would note is that at the base of the antenna, there's some of the rubber coating around the base of the antenna.